we're just getting going, and I just wanted to tell you guys there about the scientific calculator. You got to have one. It makes things so easier. All right. So where are we? What are we doing? I have posted. I was looking at the PowerPoint there that I had, and there's two ways to teach this chemistry here. Like the physics and the chemistry here, for the first half of this program, it's just math. This chemistry for the first 7 weeks is basically a math course with a chemistry aftertaste. Math tends to scare people. Don't. Let the calculator be the donkey. Okay? Please let it be the donkey. Don't be afraid of these numbers. The only thing that you have to worry about is having a formula sheet beside you, which I give to you every week. And you just have to, you don't have to know how to use a formula. You got to know which formula to use, and then plug and play with the calculator. And I'll show you guys this, okay? And it's the same with the physics. It's just a bunch of numbers. That's all it is. But I tell you, where you guys are going, this chemistry here, it's everything. Nurses, you're going to be doing dilutions. And I mean this 400 times a day, 300 times a day. You're going to be calculating dilutions in your head. And this chemistry here, you can't go on into nursing or paramedics or firefighters until you have this foundational chemistry. It's really not the most exciting stuff like today's lecture, but you gotta have it because you're going to be dealing with moles every single day. And I mean that. That's how we count things in chemistry, is in moles, as far as concentration and dilution. And you won't be dealing in moles, you'll be dealing in millimoles. You know, like meter, millimeter. These are moles, millimoles. And that's what we're talking about here. And it's all about concentration. And you know what I mean? You look at these professions here. You know, these jobs, nursing, paramedics, firefighters, the whole thing, there can't be any mistakes. You know what I mean? You're doing your bedside rounds and Mr. Clark seemed fine and your name went on his bedside sheet there and you went on and looked at some other patients and then all of a sudden 10 minutes later Mr. Brown is in a coma for some reason. They're going to come back and look at the last name that was signed on that chart and that was you. And that's why this is a very, very important lecture. All right. And thank you guys for coming. Going back to the syllabus here. This is what you got to know. And this one here, right here. This is the schedule that we will do. And currently that's what we're looking at. You never know how things are going to change, but as far as this whole course is online anyway, so I can't anticipate it changing much, okay? We don't have any Monday classes and we don't have any Friday classes, so we don't lose any classes there for Good Friday or Family Day, so we are good to go. And today we're going to be covering all of this, which is, by the way, weeks... what do we got? 11 weeks 10, 11, 12, and 13 from last semester. Today's lecture is 100% review. You've covered everything. Everything is good to go. There's nothing due today, but there are questions. And these are from the textbook, Chapter 9. And then you'll see review questions at the back of Chapter 9. It's these guys here. You will also see paired questions. These are these guys here. I have also included on the blackboard a formula page there, which I'll try and do every single week. These are the formulas there that we're going to use there today. That's been included. This one here, number of moles equal to grams divided by molar mass. This one here is the number of moles equal to the number of atoms or molecules divided by Avogadro's number. Avogadro's. Avocado. Percentage yield. This one here as well. We're going to get into, this should all look familiar there from last semester, but we're going to do it again there today just to get your brains warmed up. All right. This is what you want to have printed somewhere on your wall, and this will tell you when things are due and when things are posted. Quiz 1 will be open there next week after lecture. You will have a week to do it, and it will close before lecture week 3. All right? And I'm still working on all that, whether to, I want to go paperless and all this kind of stuff, but we'll update you there next week. Lab 1 will be posted. You'll have a week to do it. Okay, and it's due there next week, the following week. And assignment 1 will be posted week 3, and it'll be due, and this is how it'll all go. Okay, so this is the course in a nutshell. Again, if you guys have any questions, just shoot me emails. I'm recording this currently, and so I will post this there to YouTube so that you guys could stop and start it. And I've got a whiteboard which I'm currently putting up, and I'm going to try and get, because this is heavy duty, well, not heavy duty math, but it's math. And I'm going to try and get me in front of the whiteboard. We'll see. Okay. If you guys got, I don't think there's really anything too crazy other than we're just kind of, hi, how are you? If anything pops into my head, I'll mention it, but we can get moving. All right, here we are. These are the objectives there that we're going to cover there today. Introduction to Stoich, mole, mass, and limiting reagent and yield calculations. This is all a review from last semester. How it normally works, there's 2 ways of doing the mathematics on stoichiometry, and I'll show you there when we get into the meat of the, this is, I've changed, last night at around 6 o'clock, I was just looking at the PowerPoint there that I uploaded, and it's kind of the same PowerPoint that I've used every year, but I figured there that since we're totally virtual here, I didn't like it, so I stayed up all night and just changed it. That's what I do. So, here we are. So let's have a look. This is the new PowerPoint. You'll see it here, week 1 alt. It's easier for me to teach. I've left the other PowerPoint up there because there's a different kind of mathematics. You get the same answer, and I want people to learn however you want to learn. My way is not the only way, you know, so there are different ways to do things. So I've left the other PowerPoint up there. The questions, you'll see the exact same questions here, but done in a different fashion. I think they're easier. I like to use formulas. Formulas, you don't have to memorize them. They're always there. They're on a piece of paper right beside you. And I'll probably even include them on the final test as well. All right, but you guys got them. The tests are open book. Everything's open book. So please make sure to maintain an up-to-date, I will provide you an up-to-date weekly formula page that incorporates all the formulas that you'll need. Okay. Just to start things off, I made this there. You'll see a whole bunch of new slides there. It's been a long night. The itinerary of a chemical reaction. What I need you to understand is at the start of a reaction, there are 100% reactants and 0% products. Now, and if you look at this reaction here, A plus B produces C plus D. Well, at the start, you've got 100% of A and B, and you ain't got nothing of C and D. That's how a reaction starts. You mix A in one bottle and B that's in another, you mix them together. And then as the reaction starts to progress there, the amount of A and B is going down. And the amount of C and D is going up. Correct? And then towards the end of the reaction, or at the end, we don't have any A and B left. We've only got C and D. For right now, that's how I want you to understand how a chemical reaction is as far as the amounts go. So at the start, you've only got reactants. At the end, you've only got products. I I don't know who your teacher was there last semester and whether you guys use formulas. I really like these triangle formulas. And if you're in my physics class, that's all we use. And how these formulas work, you just cover up what you're looking for, and that'll tell you what you need. So if you're looking for grams, well, cover up grams. So grams is equal to the number of moles times molar mass. If you're looking for the number of moles is equal to grams divided by molar mass. If you're looking for molar mass is equal to grams divided by the number of moles. So that's how these little triangles work. And they're really, really great. I find that my students have had good success with them. There are other ways to solve these problems, but this is this one here. Hopefully that looks familiar. And please note that this number, the molar mass, you always have. This one here is never an unknown because you always have your periodic table, which I included one, a printable one there that you can, and I included that there on Blackboard. So you always have a paper copy of periodic table. So molar mass you always have. Another triangle formula you're going to use, is the number of atoms or molecules. And again, you'll see here the number of moles is equal to the number of atoms or molecules divided by Avogadro's number. This one here, you always have. Okay? And again, use the thumb, cover up, and that'll tell you what you're looking for. If you haven't seen these there before and you have any issues, just email me. We'll sort you right out. Stoichiometry. Now that you guys are coming into Bio 1032, the first part of the Bio 1031 was probably pretty boring. I've taught that one, the micro. And 1032 Bio is now you're into the macro. And I always tell my students just get through 1031 because 1032 is really, really fun. Because, 1031 is all about cell organelles and all these microscopic things, Golgi apparatus and, things that I have no idea about. But the 1032 is all about organ systems. What is it? Week 1, muscle. Week 1, bone, muscle, lymph, cardio, digestion, respiratory, renal. It's a really, really good course. And the body works in this way. What we've got here is a chemical reaction. A plus B produces C plus D. But we have these coefficients out front. And what these mean is some amount of A reacts with some amount of B to produce some amount of C and some amount of D. And these aren't random numbers. Okay? They mean something, and we are all over these there today because the amount of reactants you have absolutely corresponds to the amount of products you will make. If you're missing some of these, that's going to affect this. So using X moles of A, how much C will be formed? You can't answer that because I didn't give you any numbers, but this is what we're looking for. This is moles, 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 moles. All right? So let's have a look here. Here we've got this equation. Here we've got 2 moles of hydrogen gas plus 1 mole of oxygen gas produces 2 moles of water. What I want you to do, the first thing for any of these things, please, 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 right above, and my tests, I'll give you a piece of paper and you know what I mean, I'll give you guys a question and I'll give you the chemical equation like this. And you can use this to manipulate and use this to answer your question. I'll show you when I have some examples here that I show you here. But the very, very first thing I want you guys to do is write what's called your molar ratio. This is the most important thing of everything. So from your balanced chemical equation, it's got to be balanced. You may have to balance it. All right. You write above 2, 1, 2. That means 2 moles of this and 1 mole of this produces 2 moles of this. And the whole point of this is that now we can create a ratio, a comparison of one banana to another banana, or orange, or something like that. So you see here, there are, in this particular example, there are 6 possible ratios. So you see, I can compare the amount of hydrogen to the amount of water. 2 moles of this will make 2 moles of this. 1 mole of this will make 2 moles of this. You see? That's the kind of thinking of where I want you guys to be. All right? Just a comparison. So, let me see here. Did I put any animation? Yes, I did. So let's have a look here. There we go. Now, I move this down here. There we go. So you have a look here. If 4 moles of oxygen are present, how many moles of water could be formed? So how I want you guys to see this is, I'm going to give you a balanced chemical equation here, which we have. It's balanced. I got 4 hydrogens here, 4 hydrogens here, 2 oxygens here, 2 oxygens here. If you guys can't see that, email me, let me know. We'll straighten that right out. This is a template. This is your guide. This is going to help you through everything. And the very first thing you do, you write in your molar ratios. 2, 1, 2. So this is how this reaction works. But I'm going to give you 4 moles of this. And the question is, how many moles of this can be made using 4? Because normally this reaction is 2 and 1. So 1 of these guys will make 2 of these. So how much can 4 of these guys make? And you see what we've done? We now have a box. All right? And I call these the boxes, and this is how I get these to go. And you take these numbers here, 1, 4, 2, X, and you see here 1 mole of O2 over 4 moles of O2. They stay in line, they stay in line, 2 over X, 2 over X, and then you cross multiply. 1 times X is X, 1X. 2 times 4, so we have X is equal to 8 moles. And if you think about that, if 1 mole can make 2, double, 4 moles of this will also make double, which is 8. So if you don't like this method, there's another method on the other PowerPoint. And normally how I would do this course and how I've done it there for the past 4 years is I have the other method on the PowerPoint screen for those of people who like it, and then I do this method on the whiteboard. So I've kept both methods. One is on the other PowerPoint. This method is on here. You can choose whichever one you like. You get the same answer, and I don't care how you do it, just long as you can understand it in whatever way you can. And if you're having issues, just email me and we'll sort it all out. Okay? So if 1 mole of oxygen are present, how many moles of H2 can be formed? The answer is 8 using this methodology. Let's have a look here. Mole problem solving for stoichiometry. Just to go back, this molar ratio here, this is a moles. This is a moles. And you see here, the information I gave you is in moles. So everything is in moles. I know, it sounds stupid. But if you see a mole question, breathe a sigh of relief. These are the easiest. you can see here that the mathematics isn't too bad. All right, you do your molar ratio. This is the information on the bottom there that I've given you. You do a box, cross multiply, spit out your answer. That's a mole. Okay, and I made this very ugly diagram. It looked very good last night at midnight, but don't be confused by it. You can see here that moles of known, as long as you've got a balanced equation, you can find moles of desired. So this is a mole situation. This is as easy as it gets. And I put two examples here. Okay, here we've got 1 mole of H2 plus 1 mole of Cl2 produces 2 moles of hydrochloric acid. And the same for down here, 1, 6, 6, 6. This is all in moles. These are the easiest. But you can see here that I covered up. There are other sections in here that we're going to add. So in probably about 5 or 6 slides, these blue sections are going to be gone, and I'm going to throw something else at you. But for right now, we're just going to do a couple questions of mole calculations. All right? So, and I'm very big on answers. I'm not really great on not giving you guys answers. You guys have paid the big money, and I think you guys should have all the answers there that you guys paid for. So let's have a look here. So given the following balanced chemical equation, write the mole ratio needed to calculate. So here we've got one chemical reaction, but I'm giving you 2 questions on it. So let's just break it down step by step. And I apologize there that you can't stop and start the video here, but I'll post this there to YouTube and you guys can start and stop it. And because hopefully there you guys have a piece of paper and a pen and you'll be writing some of these guys down. So here we're looking for the moles of H2O produced from 3 moles of CO2. So I've got this here. I've got carbon dioxide plus 4 hydrogens produces methane, 1 methane, and 2 waters. First thing you always do is you write this mole ratio up here. 1, 4, 1, 2. Okay? Now, go to the question. What is it looking for? What information does it give you? So we want to calculate the moles of H2. So there's an X here. Produced from 3 moles of CO2. Bang, right here. Everything else is junk. We don't need any of this stuff because we've got our box. This is in moles. Moles, they're asking for moles of H2O, right? Oh, sorry. They're asking for moles, and they give you moles. So everything's a mole. This is a mole. You'll see here the ouch is green. It's not too bad. So 1 over 3, 1 over 3, 2 over x, 2 over x, crisscross. You get x is equal to 6 moles of water. So that means that if you have 3 moles of carbon dioxide, in theory, you can produce 6 moles of water. That's all this is. It's about predicting where the reaction is going to go or can go. All right. We're on to B now. Same chemical reaction. But here we want to find out the moles of H2 needed. So there's an X here to produce 3 moles of water. Do you notice here that the top never changes? Because it doesn't change. This is, I don't know, inscribed in stone. It never changes. All right, so that's why the very first thing you do every single time is do your mole ratios, because that's your go-to. And then these numbers here are what I'm going to give you from the question that you're going to utilize to solve the question. So again, here's your box. 4 over x is equal to 2 over 3. 4 over x is equal to 2 over 3. X is equal to 6 moles of H2. So if I provide 3 moles of this, I had to have started with at least 6 moles of this. That's how this goes. Once you try these a couple times, they become pretty cake. Okay. Here's another one. Another mole. Green, ouch. It's not too bad. So here is your chemical formula. Okay. We got, here's your molar ratio. So 2 of these guys produces 2 of these guys and 3 of these guys. Well, what am I asking for now? We want to calculate the moles of KCl produced when 4.5 moles of oxygen are formed. So here's your box, crisscross, away you go. Okay? We can keep going on these, and I will. And I want you, because this is the foundation. This is mole. These guys are the easiest. So this is where I want you to be stars. All right? If you can knock these ones out of the park in about 15, 20 minutes or 10 minutes when we get into ones that are a little bit more involved, if you've got the foundation down, they won't be bad at all. So we've got another formula here. All right? And I'm just going to pull these out. How many moles of CO2 will be produced by a reaction with 2 moles of glucose? So you got your molar ratio, you've got your information there that you need, you crisscross them, 1 over 2 is equal to 6 over x, and your answer is 12. So if you have 2 moles of this, you can make 12 moles of this. That's all these are. We're just predicting what in theory can happen with these reactions. All right. Now, I haven't figured out your. I have your quizzes and these kinds of things. We're mainly going to go with multiple choice because you get more bang for your buck, basically. But I think I will try and incorporate some writing questions, because the problem with multiple choice questions, it's either right or wrong. It kind of removes me from your learning process. And, you know, when I've taught calculus or heavy duty chem and organic chem and all these, where it's 3 or 4 whiteboards long to finish one question, a question like that would be worth 10 marks, and the final answer is only worth 2. All right, so there's got to be room for part marks. And we're at the end of this, wait until you see one of the questions. It kind of turns into a bit of a beast. But that's all right. As if you've got this foundation, you've got your chemical formula, or you've got your equation right here. You do your molar ratio, and then input the information there that the question is requiring and gives you. And then do your boxes, away you go, and that's how that one goes. Okay. What do we got here? Another mole. So this one here, a green, ouch, not bad. I think the yellow is coming next. So we got 4 aluminum and 3 oxygen molecules produces 2 moles of aluminum oxide. How many moles of aluminum are produced when 0.5 moles of oxygen react? Okay. 4 over x is equal to 3 over 0.5. Crisscross, x is equal to 0.7 moles or 0.67 moles. Okay. That's how these ones go. Mole are not bad. Now, here we go. Calculate the number. Now we're going to go back. We're going right back to 1008. Calculate the number of atoms in 36 grams of carbon. Now, we've seen these formulas there before. So let's go back here. If I want to calculate the number of atoms in 36 grams of carbon, which formula will give me the number of atoms? Well, I've got number of atoms, molecules, moles, grams, number of moles, molecular mass. Okay, so this is my formula. Okay, the number of atoms and molecules. This is the formula I'm going to use to solve this question. It's the only formula that I have that has the number of atoms. So I have to use this formula. Okay, so I need, in order to solve this, I need the number of moles and I need Avogadro's number. Well, I don't have the number of moles. I have Avogadro's number, but I don't have the number of moles. That bad teacher, Mr. Ian, he didn't give me the number of moles. So I can't do this question. But using this other formula, you can. See, I only gave you grams. There is no grams over here. So how can you solve this? Well, grams is here. I always have this one. So I can, you see here I have moles, here I have moles. I gave you information here. You always have this one. So you can solve for the number of moles, jump it over here, you have this number, and you can find this number. Again, this should be review. I hope it's review. If it's not, I'm sure I'll hear about it. But these aren't too bad, where I want you to find me an answer here, but I'm going to give you information for here. So you got to find the number of moles using this information, kick that number over here, and you always have this information, so therefore now you can solve this answer. Okay? And in my physics class, even if you're not in my physics class, get used to this. The physics there's probably, I don't know, 15 or 20 of these triangle formulas for, I think, Unit 2, maybe 10, somewhere in there. Again, don't freak out. You don't have to memorize them. They're all there. I'll give them to you. But that's how these triangle formulas work, where I will give you information for one triangle, but you'll have to plug it into another triangle in order to find the answer. So it's basically using two formulas to get one answer. We'll get there. So the reason why I just did that previous slide there, a little bit of grams and number of molecules, because you remember there what we did there before. It was only mole. I gave you moles, and I was asking for moles. Well, now I can give you grams and ask for moles. I can give you grams and ask for number of atoms. I can give you grams and ask for grams. I can give you molecules and ask for any of these. So there's a lot of room to play with. So let's try some out here. You'll notice the outs level has gone up because, let's have a look here. How many water molecules are produced when 0.01 moles of oxygen react, given the following balanced equation? So first thing I do, whatever it is I'm doing here with stoichiometry, first thing I do, bang. So here I got 2 moles, 1 mole, and 2 moles. What's the information given or asking for? Well, it's giving me 0.01 moles of oxygen. So here I got mole, 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 but it's asking for molecules here. Oh no. It's all right. All I've done is I've given you an extra calculation to do. In order for all these mole, I'd give you all moles, I'd be asking for moles. So what I've done is I've given you mole, mole, mole. You've got 3/4 of your box. So you can find this in moles, and then at the very end, you convert it to molecules. So let's have a look here. The information, I've got 1 over 0.01. Those are moles. Here I've got 2 moles over X. We'll deal with the molecules later. So 2 moles of water over X moles of water. Simple cross, exactly what we've just done there before. We get an answer of 0.02 moles of water. That's a good answer, but it's not what the question is looking for. The question is looking for molecules. So how do I change 0.02 moles of water into molecules? You use that formula. So we're looking for number of molecules. Well, I just found the moles. We always have Avogadro's number. So number of atoms is equal to moles times Avogadro's number, which is this one right here. And I apologize, this is not, and this is molecules, but I just ran out of space, so you'll see that there. Okay, so let's, that's what this one is. And you see, it's mole, but it's got an extra step at the end because it's asking there for molecules. That's all this is. So the ouch level just went up an extra step. Look at this one. Here we're in the yellow as well. What mass of hydrogen can be produced when 6 moles of aluminum react with hydrochloric acid? So here I've got 2 aluminums, 6 hydrochloric, 2 aluminum chloride, and 3 hydrogen. Bang. There's my molar ratio. What is this thing asking me? What mass of H2? Ooh, so it's asking for grams here. And it's giving me 6 moles of aluminum. So again, everything else is junk. Don't need it. I've got my box. All right. Moles, moles, moles. Let's go. So 2 over 6, 3 over x, right, is equal to 9 moles. That's not what the question is looking for. The question is looking for mass. So how do I change moles into mass? You use one of your triangle formulas that has mass, and you'll see number of grams of hydrogen is equal to moles times molar mass, and 9 moles, which we just calculated. 2 grams per mole is the molar mass of hydrogen. Be careful. When you're figuring out the molar mass of hydrogen here, okay, know that there's 2 hydrogens, 1 and 1, which is 2, right? You'll see up here, do not include, even though there's a number up here, that do not include that number in the molar mass. The molar mass is just the H2. All right? That's what you include there for your molar mass. You calculate it out, 18.1 grams of hydrogen. So 6 moles of aluminum can make 18.1 grams of hydrogen, which is also 9 moles. I hope this is going all right. Normally I would just pause and take a break and have a drink of water and just let you guys hit me with questions there for 10 minutes. But let's just hold off on that until we can get it pre-recorded and you guys can have a look at this. And as far as questions go, please ask them. Please, because if you've got a question, guaranteed there's 10 other people who have a question that are probably too afraid to ask. And if it's a good one, I'll post it. And because collective learning, social learning, that's what it's all about. So please don't be afraid. I'm not one of those teachers there that doesn't like students asking me questions. I actually enjoy it. Test me as a teacher. Ask me. Don't be afraid. You guys paid the big bucks. Ask as many questions as you like. Oh, and also the golden rule when it comes to homework, do a question twice, and if it still doesn't work out, email me. Do not do it a third time. Do not waste your time. I've had students spend all night on one silly question, and you know those silly textbooks there that the school makes you buy, what are they, $200-300, and they're all peer-reviewed by PhDs, and they're riddled with mistakes. So one student there spent all night doing one question, and there was a mistake in the back of the book. And so please don't waste your time. Do a question twice. If it doesn't work out, shoot me an email. Say, hey, Ian, question number 8 on page 52 is irritating me. It's not working. I've done it twice. Can you see if there's any issues? Bang, I'll do it. I'll shoot your reply. You didn't waste any time. Okay? Good. Now, you'll see here that I apologize. I know it looks kind of penny-ante, but really it's the best thing that I could do at the moment. We'll see about uploading some video. I'm going to see if I can embed some video into these things, but we're going to see. But I'll walk you guys through this, not a problem. How many moles of water are produced when 325 grams of octane are burned? So here is the balanced chemical equation right here. Very first thing you do is I write it out, and just to make sure that it's balanced and everything is good. So I just basically put it right there. you put up your molar ratio, which is 2, 25, 16, and 18. Input the information there that I'm looking for and give you. So we're looking for how many moles of water are produced. So X moles. So it's moles, 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 when 325 grams of octane. All right? So you've got this one down here. So we've got grams right then and there. Your ears should just be tingling. That's going to be an issue. Okay? Because we only deal in stoichiometry with moles. So this is 2 moles, 18 moles, X mole, and here we've got grams. I can't do anything at this point in time. First things first, I need moles across the board. I've got moles here, okay, moles here, but I got grams. So you have to kind of, and I don't know, you could do it a different way. I just wanted to emphasize that you kind of have to take this out to the side of the page. You've got to manipulate this. You've got to change this back into moles and then dump it back in. So here we've got 325 grams of octane. Well, you've got to convert this to moles. Go back to your triangle formula. Number of moles is equal to grams divided by molar mass. Well, number of grams is 325 grams. Molar mass is 114 grams per mole. Just do a quick Google search, okay? Or you could just add up. Carbon is 12 times 8 plus hydrogen is 1 times 18 and adds up to 114. But anyway, the number of moles of 325 grams of octane is 2.85 moles. What you got to do is you got to sub that back in now. So this is 2.85 moles. So you got moles, 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 and moles. Now you can do your box. And crisscross, X is equal to 25.6 moles of hydrogen. Or sorry, of water. So this is a really, really good question. I like it because I can't stress enough. The stoichiometry has to be in moles. But you see, before when it was mole, I would just give you moles. But now I can give you grams. I can give you molecules here. And you've got to take that out, convert it back into moles, pop it back in, and now you can do your box. Okay? Look at this one here. How many grams of silver nitrate are needed to produce 0.25 moles of silver sulfide? So, here you've got this, your same chemical reaction, chemical formula, and your molar ratio, which is 2,112. Okay, what am I looking for? How many grams of silver nitrate? X grams. I give you 0.025 moles of silver sulfide. Okay, now this one here is the opposite of the previous one. You remember the previous one there? I couldn't even do a box because I didn't have all moles. Well, look, you have moles, you have moles, you have moles. You're looking for grams. So this one here you can do at the end. So here, do your box first. Okay, check. Have all moles. We do have all moles. 2 over X is 1 over 0.25. X is equal to 0.05 moles of silver nitrate. Question is asking for grammage. Plug that into your formula. And somewhere in there, it's there. Okay. And it's 84.9. Okay. So this is what we call mole mass. All right. So the ouch factor is upped a little bit.
Ian, I'm sorry to interrupt.
No, please do.
How close do we have to be? I remember last semester we had a lot of discrepancies because our periodic table weights were all different.
Oh, I hear you on that one. I hear you. The I'm not a stickler. Like if for multiple choice questions, there will be one answer. You know what I mean? Like like for this one, what's this answer here? 84.9. You know what I mean? The choices would be, and I'm just making this up right now. A would be 84.9. B would be 93.7. C would be 108. And D would be 75. You know what I mean? There's really, you know what I mean? And when it comes to periodic tables, you're right. They all are different. Like your periodic table, I think for hydrogen is 1.008. For my periodic table, it's 1.00797. And it's okay. And if there's any issues, I'm not really into, like, as far as significant figures go, yeah, but I'm more into, can you get the chemistry? And so, great question. If you got an answer in and around 85, there will only be one answer that is around 85. Okay, and if there's any issues, you know what I mean, you get your test back and there's some, just email me. I'm pretty good, man, with marks. Okay, so I have no problem. I'm not afraid of giving A's, A pluses. I even think someone got 100% of my final. It's outrageous, and I love it. Come and get it. That's what it's all about. And good question, by the way. Thank you very much. Hopefully I answered it. Probably didn't. All right. But
I have a question since we're on the topic of tests.
Yeah.
If we have 40 questions, are we going to have like 40 minutes, or are we going to have a little bit of extra time?
Pretty. You mean like final tests?
Yeah, anything where we are more so working things out and writing things down. Like I know last semester, anything like that, we had pretty much the same amount of time as we had questions.
Ooh.
So it was a little bit tight, but I'm just wondering, because I know our final, he gave us an extra 10 or so minutes because we had to write things out, but I'm just curious.
I'll give you 3 hours. I think that's the maximum I can give you. Just to be clear, actually that is a good question. Some of these questions, they'll take you like 10 seconds. Some of them will take you like 5 minutes. And you have to think, how many of those smackdown questions am I going to give you, right? And is it really, you know what I mean? There will be 2 or 3 of them on a test. But as you'll have more than enough time on the test, I promise you. You guys will be just fine. Somewhere in and around probably 60 or 70 questions. But you'll have 3 hours. And some of them, like, wait until we get to some of these coming down here. But good question, though. So you'll have a lot of time, and don't worry about that.
So one last question about tests.
Yeah.
Are we going to, like, you have the 2 tests, so the first test is going to be based on the first half of the semester, second one's going to be based on the second?
Mucho bueno, I love it. Excellent question again. Basically, in this course, you got 2 finals, and most people enjoy either one or the other. The first half of this course is a math course. It is, with a chemistry aftertaste. That's all it is. We're just doing calculations, and because all of you are going to be doing calculations in your head for the rest of your life as far as these kinds of things go. And we'll do the first 6 weeks. We'll have the week 7 test. And then week 8 is organic chemistry, which I think is the most fun. All right. And if you're not necessarily a math person and you're more artistic and you think more spatially, the second half of the course, you'll just rock it. You know what I mean? If you're a numbers person, this is your half. And the next half of the course is actually, I think, is the most fun. It's more 3D. It's more spatial. It's organic chemistry. It's atoms interacting with each other on a molecular scale. And you have to think, when you guys get into enzymes and bodily functions, all right, molecules, even the vaccines that are going out right now, it's all spatial. It's all lock and key. And it's just amazing evolutionarily. You know, whatever you believe, you know, the whole idea of evolution and the evolution of enzymes and bodily molecules and how they fit together. And basically, you look at your body's defenses against outside organisms. Well, the only reason an organism is causing you trouble is because your body doesn't have a key to fit its lock, right? Doesn't have a defense against it. And that's basically what a vaccine is, right? I'm skimming the surface incredibly thin here, but you can kind of get the idea. So getting back to your question, they are completely different. I've had students do not so well on one and then get 99 on the other, and they're all, you know, the one girl there, she's at Western. You know what I mean? So it's okay. Just keep at it. Do not let go. Do not give up at any point in time. If you're having issues, you make sure you email me, because all of this is important. One of the halves of the courses you will like, the other half maybe not so much, but get it anyway. Okay? Good question. Keep them coming. Any more? I'll have a coffee for 10 seconds. Coffee. No, we're good? Okay. Again, I'm not really happy with this, but there's really nothing I can do. And until I can get a whiteboard functioning and go step by step. But that's why I've kind of put numbers in here. We'll see. How many grams of chromium chloride are required to produce 75 grams of silver chloride? Wait a second here. Whoa. What? How many grams of this are required to produce grams of this? Great. I don't even have mole anymore. And you see here, I rewrote it, same thing. So there's my chromium chloride, silver nitrate, chromium nitrate, and silver chloride all right here. I've got my molar ratio, 1,313. First thing, do that. Now plug in what I'm giving you and what I'm looking for. Well, I'm looking for grams of this. And I give you grams of this. It's okay, you can silently curse my name if this happens in a testing situation. I'm okay with it because there's going to be some work involved here. This, remember the ouch level? Now the ouch level is red. And it's not like it's any more difficult. If you go back here, where was this one right here? You remember this one right here where you had, I gave you grams, you had to pull this out, change it to moles, put it back in, and then go for it. Well, that's basically what we're doing here. It's just now you gotta, there's an extra conversion. And so you've got your molar ratios here. I'm looking for grams. I give you grams. Well, this is grams, moles, moles. So here's your box, but I don't have all moles. So what's the first thing you got to do is you have to change this to moles. And that's number one here. Must change to moles. So 75 grams of silver chloride is, so it's grams divided by molar mass, 75 divided by the molar mass. You can Google that, okay? And there's your number of moles. So 75 grams of this is equal to 0.523 moles. So sub that back in. So that should be 0.523 moles. Moles, moles, moles. I can do a box. Right there. Do your box. 1 over x is 3 over, what was that? 0.523? Yeah. Which is right here. You do your box. X is equal to. All right? And you get a number there, and away you go. This is, and we've got grams is equal to, and you see we figure out, what is it here? 1 divided by, and you figure out what x is here, your number of moles here. Okay, and you plug it all in, and you get your grams. Now I've got 0.523 times 158. You get 27.6 grams of this right here. It's all based on the moles. when it comes to, that's why I did 5 or 6 questions of mole. And as long as you got that system down, see, if I give you moles and I ask for moles, it's a green ouch. It's an easy question. But if I give you grams, you got to convert it. Or if I give you molecules, you got to convert it. You have to convert them both to moles. And then you're going to spit out moles. And then maybe I could ask you grams or molecules on the tail end. That's how these guys go.
Can I just ask something?
Yeah.
I always wonder from the last time why we're doing it this way. There's an easy way to do this.
There's lots of ways to do this. And that's
because,
why
you can't find just the molar mass for each compound and compare it. Like just a gram by gram. Why I have to convert it to moles?
If you have a question about this, email me and we can have a WebEx chat on that. I want to keep there's this way here, and then there's the other way that I posted on the other PowerPoint. And this way here uses these formulas. That's all we've been doing for these higher level ones. When if I give you grams, you convert to moles. If I give you molecules, you convert to moles. And these formulas here you kind of have to use, but there's different ways on doing this. If you check the other PowerPoint, it's called the factor label method. And maybe that works for you. That's why I posted both ways. And I would have put both ways in the PowerPoint, but then my PowerPoint would have been 60 slides long. And I would have had 2 competing methods in one PowerPoint, and I think I would have had more confusion than anything. So if you guys are familiar with the factor label method, which I'm going to... Where did all... There we go. Why did that just disappear? Okay, let's go to week 1. And you see here, week 1. And you see, here is the week 1 that's also posted. And you see what it does is, it uses what's called the factor label method. You remember the octane one we just did? And it uses the factor label method. And some people really enjoy that method. And it's all good. It really is. You get the same answer. I find that the majority of people prefer to use a formula. Those triangles. And that's the way I'm going to kind of go after this. But please don't feel that you need to do it like I do it. If you like it, the factor label method, then use the other PowerPoint and go for it. Okay? Good question. And if you have, I have no idea why that is. There we go. Okay. But if you feel that you want to use the other factor label method, go for it. You get the exact same answer anyway. Okay? I hope that works. And if you have any questions at all, just email me and we'll work through it. Okay? Where are we here? I think we're kind of at the... Yeah? Hello?
Hi. I'm looking at the Blackboard and I'm not seeing the PowerPoint listed in the weekly learning. Is it uploaded or are you doing that after? Or?
The new... They should all be there. If it's not, I'll check it out all after. And I'm going to post this video again there to YouTube. I wanted to try and meet you guys live because I do enjoy this better because of the questions. And it's just a matter of getting it all functioning. And I'm going to do that there for the physics there next week, I think. I enjoy this a lot better. And as soon as I'm done this, I'll upload the video there to YouTube. And then you guys can stop and start it. And then hit me with questions all week. And what I would like to do, and maybe you guys can give me some feedback on this, during the lab class, you don't have to do the lab. Honestly, the labs are pretty easy. If we could use that as a tutorial time, if you guys have any questions at all, or even, I'm free most of the week anyway. So if you want to set up an individual WebEx, I have no problem doing that at all. And we could, hopefully there by tonight or tomorrow, I'll have the whiteboard set up. So I'm I got a little camera tripod, got it on Amazon, and just getting it all up so that I'll be in front of a whiteboard where I belong. So good stuff. Where are we here? Alt. I think we're pretty much at the tail end. Where are we here now? Yeah. And I know that this looks like a mess, but if you have, the answers, I posted all the questions and the answers. You'll see here, review questions 1, Q&A. I've added these. These are actually, they're really simple, but they're really good for strategic mathematics skills. Like determine the number of moles in each quantity. You got 25 grams of silver chloride. Bang, bang. You're just punching out numbers. You're just using your calculator and calculating molar mass and these kinds of things. Good little practice determining the number of grams in each quantity, because I don't think you guys have done this in, what, a month. So these are all good things there that we'll be doing on a weekly basis there in this course. Identify how many molecules are in each quantity. Don't do them all. Do 1 or 2. Just get back in the groove of using those triangle formulas. Identify how many moles are in the number of molecules. So here we got the number of molecules. How many moles? How do you figure that out? Here we've got some balancing in chemical equations, just if you need some practice. Don't do them all. That would be silly. All right. Here we've got some more mole-mole problems. Here we've got mass problems. How many grams of potassium chloride are produced? They're right there. This is exactly what we're doing right here. What we did there last semester. Limiting reagent problems. Okay. This one here, what mass of hydrogen? Sorry, not too pretty, but these are we're going to get into what's called the limiting reagent there again. You guys did that there last semester, and all the answers are here. Okay. And if something, again, I've gone through it, but if there's anything that's not making any sense, do a question twice and then email me. Okay, so there are those questions, and I actually put other questions, and these are from the syllabus. And I think the syllabus is where? In the syllabus, you'll see there for week by week, you'll see the, remember the paired and the, what was the other question type? Anyway. That's where those questions are found. And I put all the questions and the answers there. And you'll see there that the answers are like the factor label method, the other method. Okay? And the questions and answers are all there, and how to do it step by step. And again, don't try them all, because then it just becomes redundant. But if you go to your textbook, find those questions, you can try those questions out. You've got the full answers right there. Okay, so there's a lot of work there that don't do it all, but there's lots of questions there that you guys can do. Basically we're at this is the end here, the limiting reactant. How this works is you need a certain number of pieces to put a bike together. And you know what I mean? You got all these tires, you got all the frames and all this, but then if you're missing some pieces, you have some leftover pieces. You have some excess. I like that word. We're going to get back into that, excess. You have some excess pieces. So even though you have all of this, how many bikes can you make? Well, I only got 3. I have some extra pieces here. So this is where we're getting at here. When we go back to, you remember slide 3, this one right here. At the start of a reaction, we have all of this. We don't have any of this. And then the numbers are decreasing, increasing, and at the end it's reversed. Well, let's get back to this one right here. If you started with 5 molecules of hydrogen and 3 molecules of chlorine. So here's my reaction. I got hydrogen gas, chlorine gas, produces 2 hydrochloric acid. Again, you're doing your same molar ratio, 1, 1, 2. But the question's asking you, if I started with 5 molecules and 3 molecules, how much HCl could you make? Well, So this is my molar ratio. This is what's etched in stone. Never changes. Well, here I'm giving you 5 molecules and 3 molecules. How much of this can I make? Because look at the ratio here. 1 of these will make, and 1 of these will make 2 of these. So the ratio is 1 to 1. You see here now, I've got 5 of these and 3 of these. Which one am I going to run out of first? Ratio 1 to 1. So I've got 5 of these guys, 3 of these guys. This is a very simplified one. Okay, so you'll see there, the ratio is 1 to 1. The reaction will shut down when the 3 molecules of chlorine finish. And you see here, so basically, the start of the reaction looks like this. I've got 5 and 3 and 0. Well, I've got too much of this one. And this one here is going to shut down the reaction. So once these 3 molecules of chlorine are gonzo, the reaction will stop. So really, the reaction, the end of the reaction looks like this. Hopefully there, and I have 2 molecules of hydrogen left over, right? Because I started with 5. I can only use 3 because I only have 3 chlorines. And so the hydrogen doesn't have anything else to react with, so there are 2 left over. And you see here, now, how many molecules of this can I produce? Well, you can do a box right here. 1 over 3, 2 over x. And this one here, you don't even really need to do a box. 1, you double it, you make 2. 3, you double it, you make 6. And don't forget about the extra hydrogen. There's 2 extra hydrogens there, and they are what we call in excess. So this is called the limiting reaction. There's a couple things here, problem-solving strategies. You want to calculate the amount of product formed from each reactant present. But first things first, you want to make sure that everything is balanced and your molar ratio is clean. Because if there's a mistake in your balancing, that'll affect your molar ratio, which will most certainly 100% give you a wrong answer out of the end. So if it's balanced, I will tell you. If it's not balanced, I will also tell you. There's no games here. I'm not trying to trick you. All right? I want you guys to walk the path. The path is lighted. All you got to do is walk it. Okay? Number 2, the reactant that gives the least amount of product is the limiting reagent. The other reactant is in excess. Hopefully this should all be kind of review. The amount of product is determined by calculation from step 1. And if the amount of excess reactant is desired, sometimes I will ask you for how much reactant is in excess. And we'll show you these right here. What do we got here? Now, okay, let's go. So, here I've got this. How many moles of hydrochloric acid can be produced from 4 moles of hydrogen and 3.5 moles of chlorine? So, what's the first thing we got to do? You fill in your molar ratios. So how many moles of hydrochloric acid can be produced from 4 moles of hydrogen? So we've got this right here. But we also have 3.5 moles of this. So which one of them is going to finish first? Because we've got 4 moles of this and we've got 3.5 moles of this. So what we need to do is we need to break this up into 2 different things here. There's one box. We need to do a box. And that's going to tell us how much of this I can make using this number. We're going to do another box. And it's going to tell me how much of this, again, I'm going to make using this number. So we do 2 boxes here. And 1 over 4, 2 over x. Okay. In this particular case, I can make 8 moles. in this particular case, I can only make 7. And you see, if you go back to the previous example where it was kind of easy to visually see it there with your eye, in some cases you can't. And this one here, you didn't really need to do these boxes, but it's still a kind of a simplified situation. You can see that the molar ratio was 1 to 1. I start with 4 of these guys, 3.5 of these guys. These guys here are going to run out. So therefore now this is your limiting reagent. And that's what we've got there. So this reaction, the maximum it will make is 7. So in this case here, I call this statement a false statement. This one here is the true statement because the chlorine is the limiting reactant. Okay? And we've got these right here. Try this one right here. How many grams, sorry, I guess that's being covered up. How many grams of silver bromide can be produced from 50 grams of magnesium bromide and 100 grams of silver nitrate? This is about as tough as it's going to get. All right? And this one here is the extreme. And there, you know what I mean? There'll be an assignment. You have 2 weeks to do it, so there might be a couple of these on there. On a test, please expect 1. You know, I'm not there to. These are a smackdown. They really are. And step by step. And again, there's different ways of doing it. The exact same question is on the other PowerPoint with the factor label method ready to go if you guys wanted to do it that way. All right. But let's have a look at this one here. This one here is a good one. So, what are we looking for here? We are looking for how many grams of silver bromide are produced. So silver bromide right here. So I've got my chemical equation. I've got 1, 2, 2, 1. 1, 2, 2, 1. And that's my molar ratio. Everything is good to go. What am I looking for? I've got X grams. I'm looking for grams here. But I've given you grams, and I've given you grams. So this is a limiting reagent question, but I've given you probably, this is the most difficult of them all. Because I've given you grams and given you grams here. So remember, this is all moles. So what's the first thing you got to do? If you do anything, you got to get rid of the grammage, and you got to change these to moles before you do anything. So before we can do anything, you must convert all grams to moles. So, and I've done that here, okay, for space. So magnesium bromide is 0.27 moles. So that right there is 0.27 moles. And silver nitrate is 0.59 moles. Okay? So now we've got moles all around. Now, because this is limiting reagent, I got to do 2 boxes. All right, and that's what we've got right here. All right, it's all right. Now you've got your 2 boxes. All right, and you figure out which one are you going to make the least product of. You do 1 box, and using this number right here, 0.27 from this guy, you do a box, and you find out that you make 0.54 moles of silver bromide. You use this one right here that you just calculated up here, and you got 0.59. You do a box, you calculate, you get 0.59. You actually get the same number. Which one is your limiting reagent? This one right here, that's your limiting reagent, and then you, from there, your number of moles, you can calculate the number, okay, of grams that you're looking for, and I think that's 102 grams right there. These, again, this is all review. However you learned it, however you're comfortable learning it, go for it. All right? But this is all, hopefully, it was done there last semester. Please let me know if it wasn't. And we'll, I'll see if I can add some extra, but I think you guys have enough questions anyway to last a lifetime. But that is your limiting reagent, where you have 2 different values for your reagents. Which one is going to run out first? because when that one runs out first, the reaction is shut down, even though you still have some more of the other one. Okay? And again, you could keep going on with these guys here. You can have a look from the problem on the previous slide, how much excess reactant remains. So this is where, remember that slide there originally. We had 0.27 moles of this guy and 0.59 moles of this guy. Well, how much did we use? We used all of this guy and we used all of this, right? Because the molar ratio is 1 to 2. Well, 1 to 2. 0.54 is double 0.27. At the end of the reaction, we don't have any of this, but we only have 0.05 moles left from this guy. 0.59 minus 0.4. Change moles, okay, into grams. That's how we do this right here. And again, it's those two triangle formulas. You'll need them all the time. Next week there when we, and then especially when we get into solutions as well. And every week I will update a new formula page so that when you open up your PowerPoint, you can also print off your new formula page. So these are the formulas there that you will need for this week and for this unit. And I have it broken up into units. So it's not just all mashed potatoes where week 4's formulas are mixed in with week 2 formulas. Everything is nicely separated, and I'll show you that. Again, you can keep going on with these and keep going on with these. Have a look at these there. Okay, this is just another limiting reagent question. It's a level red. Okay, and try these out. The answers are there again on the PowerPoint as well, and the other one is there as well. You can keep doing these. The reaction. I want to finish there. The reaction yield. This will take 1 minute. This is easy peasy. This formula is also included. Okay, and what this means is the reaction yield. If I'm A plus B produces C and D, and let's say that, I don't know, I'm some type of magnificent person, being that can control atoms. Well, if you've got 500 milliliters of this solution and you pour it into this solution, well, there's still some of that solution left in the bottle that you'll never be able to get off. You've lost atoms because they're sticking to the glass inside the beaker. So you're not going to get as much product as you had hoped. Your theoretical yield indicates how much product you would get if you were a perfect being and able to control atoms. Your actual yield is going to be less than that because we're imperfect and we don't have control over atoms. So this formula here, your percentage yield, it means basically it's asking you how much did you get, comparatively speaking, to what you should have got. And the percentage yield is equal to the actual yield, what'd you get, divided by the theoretical yield, what you should have got, times 100. And these questions aren't too bad. They're just a matter of plugging and playing. Calculate the percent yield if only 3.8 moles of silver bromide were prepared, but 4 moles were expected. So silver bromide, 3.8, right here. We only got 3.8 moles, but we were expecting 4 moles. So 3.8 divided by 4 times 100 is 95%. So we had a 95% yield. Please note that if you ever get a number more than 100% for a question like this, do it again. Because your actual yield can never be more than 100%. All right? And your theoretical yield can never be more than 100%. Okay? Your actual yield will always be less than 100. That's that. These are the learning objectives there that we've covered. I apologize, man. It's a lot of information. But you know what? That's what the first half of this course is. And the best advice I can give you is just keep at these and keep in constant contact. And if some question is irritating you, I'll do it on a piece of paper, send a picture and scan it, or we'll set up a WebEx and I'll do it on my Blackboard. Hopefully they're starting tomorrow. So that's where we're at. Have some fun. Yeah. But let me know what you guys are thinking, and we'll probably call it a day. I'll stay here for a while if people want to sign off. If anyone has any questions and like that they don't mind talking about in front of other people, stay on for another 5-10 minutes and we'll talk. And other than that, thank you guys. I appreciate your time. I really do. Oh my gosh, are you guys still there? Have I just been talking for the past hour and nobody's there? Okay.
Post this PowerPoint to a Blackboard.
Oh, hello. Hi.
Hello.
Hi.
Are you going to post this PowerPoint to the Blackboard?
Oh, yeah. I'm going to post this PowerPoint to the Blackboard, and I'm going to post the video there to YouTube right now so that you guys will have all that. And if you see something there that you don't, that doesn't make any sense, just shoot me an email and we'll fix it. Because I'm not perfect. I don't strive to be, but we try and do our best. And if you see something there that looks funny, let me know. All right. Well, then what I will do is I'm going to stop recording. And right now...